Hey everyone, so welcome back to problem number 4 for day 1. And today's problem is 567 on LeetCode, which is permutation in a string. And the problem statement goes like, we have been given to a string S1 and S2, and we have to return true if S2 contains a permutation of S1 or false. Otherwise, just to be clear, S2 must contain a permutation of S1, not the other way around, okay? In other words, return true if one of S1's permutation is the substring of S2. All right. So let us move to the dashboard and we'll try to investigate and try to solve this problem. Now, we are at the dashboard, okay? We have been given to a string S1. Oops. We have been given to a string S1 and S2, all right? And we have to determine and return true or false if we have a substring within S2 such that it is nothing but a permutation of S1. Just to be clear, since S1 has A and B, okay, can this be a substring that we need? The answer is no. This is not the substring that we need, but the actual substring that we may need is, and which is actually correct, is this one. BA. So what do you notice here? We notice that the length of the substring or the window of S2, it has to be exactly and precisely equal to the length of the S1. Only then we can determine whether or not do we have such a thing in S2 or not. What could be the brute force way to approach this problem? The brute force way to approach this problem would be to generate every single substring of S2 and then go on and check such substring whose length is equivalent to S1 and then determine whether they contain a permutation of S1. How do we check whether it has permutation? There are two ways. One way would be to write a permutation function to check whether that has a permutation of this thing or not. And the second and a much more convenient way would be to check or compare their dictionary, correct? Or hash map. So what we'll do, we will have a hash map for S1, and as we proceed to try to create a window in S2 of which is equivalent to the length of the window of S1, we will we will fill the dictionary of S2 along the way. But before we proceed, what would be the edge case that we need to be worried of? One of the edge cases is that what if the length of S1 it is greater than S2? In that case, S2 cannot fit S1 within itself because S1 is much greater than S2, correct? And the question states S2 must fit on S1, right? So that is what this first statement is doing. We are checking whether S1 is greater or S2, then we return false, correct? And then what do we do next? We create a container for S1 and we assign it a counter of S1. This is a Python word. What it basically does is it generates or populates a hash map with the frequency of every character of S1 and it stores in container of S1. We declare two pointer. The first is left as a and second is right as a right. Why do we need those two pointer? We need those two pointer to maintain our window. Okay. Similarly, we create a different container S2, and we assign it an empty dictionary. Okay. Now we run through the loop that spans across the entire length of S2, and the right is the iterator over here. Left is the left window iterator, and right is the right window iterator. Okay. And as this is going on, so this will iterate through every single character and it will revolve around linear time complexity. The first statement that we execute within the loop is we add, what do we add? We add the right character value of string S2 in the container S2 and increment its frequency by 1. Pretty much simple. For example, if right, let us suppose right is here, the first thing that it will do is it will add D to the container. And if D is not already present in the container, it will add D and it will assign its value to 1. But if D is already present in the container, it will add D and it will increase its value to whatever the value previously was by 1. Okay, so that is what this line is doing. Now, the next thing that we need to check is, and again, this is a very, very significant thing that we need to check. It is whether or not the current window length of S2, which is determined by right minus left plus 1. Why right minus left plus 1? Because these are the iterators which are running on S2, whether that is equivalent to the S1. We are just asking, hey, is the window of S2 at this current state is it equivalent to the window or the entire length of S1? If that is the case, let us make a few more checks. And a few more corresponding checks are we're comparing the hash maps or hash or dictionary. Okay. If those two dictionary are equal for container S1 and S2, we return true there and there only, and our function stops. And the next line is like if this line is not executed, okay? So we come to the next line. In that case, what do? We try to shrink the window size. Why are we trying to shrink the window size? We are trying to shrink the window size because we know for sure that at this state, we do not really satisfy what we are looking for. So we try to shrink from the left. Again, remember, the left pointer moves when the condition violates or when we try to reach to a particular specific point, okay? So what do? We decrement from the left pointer by 1, and then we make a check here. Upon decrementing, has its value been converged to 0? And if that is the case, we remove that character from container as 2, okay? And then what do? We increment the left pointer by 1. And this left pointer is getting incremented within this if condition, okay? And once this entire loop is executed and exhausted, we come out of that and return false. So the only place where our answer is getting written from is at this spot within the if loop, right? Which checks whether the lengths are equal or not. Okay. So that is it all. That is all about this problem. The time complexity is order of n, and the space complexity it converges around the length of the total alphabetical English characters. Okay. What are the edge cases? The number one edge case is that what if the length of S1 is greater than S2? In that case, S2 will not be able to encompass S1. And the second thing, and the most important thing that we need to keep in mind, which is not really particularly descriptive of this problem, is that the length of the window of the permutation of S1, it has to be equivalent, right? I mean, if we are trying to find such a window, the length of the window, it must be equivalent to the length of S1, right? We cannot have a window of arbitrary length where A and B are, distributed like this, right? We cannot have such a case. They must be jumbled together like this, BA or AP. We cannot have an arbitrary length like that, okay? So that is it, all there is about this problem. I hope you understood the description. Let us move back to the LeetCode dashboard and we will try to submit this problem, okay? So I've already typed the code. I will just paste it and let us run this. And as you can see, oops, it ran. Okay, it ran, okay. And yeah, so it passes the test cases. And yeah, so that is all there is about this problem, which was like problem number 4 for today. Let us jump back to the next problem, which will be a hard problem for today, okay? Let's just go.